Alright, we're on the last couple lectures of the unit on the periodic table. Now, the previous two lectures we talked about the trends in the periodic table. Some of them were ionization energy and electronegativity, also known as electron affinity. And that's when an atom loses an electron, like how much energy it takes to lose an electron, and the atom's general pull of electrons towards it. Now, atoms can gain and lose electrons. And when it gains and loses electrons, it's going to change a lot of things about it, right? We'll talk about that soon. So, by the end of this lecture, what you guys should be focusing on is describe whether an atom will become a cation or an anion based on its location in the periodic table, and also learn what ion, cation, and anion, what they are, what those vocabulary words mean. So, let's get right into it. An ion, when you hear somebody talking about an ion, is any element with a charge. So it's either lost protons, it's either lost electrons, it doesn't lose protons, that would change it completely. It either loses electrons or gains electrons. Like say your sodium with normally 11 protons and 11 electrons. If you lost one electron, then you would now be an ion. Now, an ion with a positive charge is going to be known as a cation. You have that. I'll tell you the nomenclature. But an ion with a positive charge is a cation. And to make a cation, you have to lose electrons. Right? You lose those negative charges, then you become positive. So cation is any ion with a positive charge. Positive 1, positive 2, positive 3, whatever. Alright. The exact opposite is an anion. That's going to be an element, an ion, with a negative charge. So these are your three big vocab words to focus on. Ion, any element with a charge, and there's two subcategories, a positive charge cation, a negatively charged anion. And now, I like to use memory devices to remember this one because it's extremely easy. So here's your little science cat. I like to think positively, that's why I'm a cation. Another way to remember cation as the positive ion is, you'll have to visualize this in the head because I don't have the webcam up, but cations are positive. So imagine like a cat pawing and they're positive. Cations are positive. And if you want to make one up for anions, we can go back to the whole android idea and imagine androids taking over the world or ants in your pants, and those are both negative things, so that's why anion is negative. So cation is positive, anion is negative. Now, we have our ions that either lose electrons or gain electrons. I keep saying protons. It's either lose electrons or gain electrons. Typically, there's going to be a trend. Our metals are usually going to lose electrons. That's the name of their game. So metals typically lose electrons. Since they lose electrons, they get a positive charge, and become positive cations. Our nonmetals, the trend is typically the exact opposite. They're going to gain electrons and become negative anions. Right? So they gain electrons, they gain negative charges, they become anions. We'll talk about why in a minute. All right. So the reason they're gaining or losing electrons is typically they want to have the same electron configuration as a noble gas. So they want the same number of electrons as a noble gas. We've talked about before that noble gases are the most stable of the elements. So the atoms will either gain or lose electrons to be just like your noble gases. And if you look down that column, that group, that family, helium has 2 electrons, neon has 10, argon 18, krypton 36, xenon 54, and radon has 84 electrons. So those are our magic numbers that our elements typically go towards, right? For a number of electrons at once. It doesn't always work perfectly like that, but you'll see. Alright, so what you'll typically see on tests and things like that is trying to figure out whether something will become a cation or anion, and how many electrons it'll gain or lose. So here's your general example. Sodium. If you look at it on the periodic table, It's atomic number 11. Remember how we had those magic numbers up a second ago? Well, 11 is really close to 10 on the magic number, the same number as neon. So most likely sodium, we observe this, will lose one electron. So it had 11, it wants 10, it loses one electron. That gives it a positive 1 charge. And since it's positive, it's a cation, it's positive because it lost an electron. If you check out chlorine, it's on the far right side of the periodic table, it's atomic number 17. It has 17 electrons. If we're looking at our periodic table, we can see it's really close to argon, which is 18. So chlorine actually ends up gaining 1 electron, so that it becomes just like, what do you call? Actually, I can write. I haven't used my draw feature at all today, so I feel like doing that. So chlorine, so it gains. That was horrible. Oh wow, this is why I haven't used the draw feature. It gains 1 electron. And then it becomes chlorine, so Cl, with a negative 1 charge. Alright, so that's your ion for chlorine. That was hideous. Okay, escape. Give sulfur and calcium a shot on your own. Try to figure out how many electrons it'll either gain or lose to become stable, like the noble gases. Another cool thing you can do with electron configurations. Let's look at chlorine. Now we said earlier chlorine gained 1 electron, and here if we're looking at the orbital filling diagram, you can see why. If it gains 1 electron, it'll look just like argon and have 6 electrons in its 3p orbital, where here normally it just only has 5. Alright, so that's your insight for ions. Let me know if you have any trouble. Let's see here. I have such trouble ending videos.